wonder what actually keeps a regular brick building from crumbling to pieces when the ground starts shaking? This is the brief on earthquake-resistant design, specifically looking at Indian Standard 4326. So we're basically unpacking the survival guide for everyday structures. This code dictates how conventional masonry and timber buildings have to be designed to actually withstand an earthquake. Okay, first step, shape and weight are your absolute first line of defense. See, earthquake force is all about mass, so lighter is always better, especially on upper floors. And the code is super clear. You want simple, rectangular plans. If you've got a complex shape, say an L or a T, you have to break it up into separate rectangular blocks with these little gaps in between. Why? So the different parts of the building don't literally hammer against each other during a tremor. Second, you need something called box action. Without it, four walls are really just a house of cards waiting to fall flat. So to fix that, you install horizontal bands. Just think of them like concrete belts strapped around the base, the windows, and the roof. They tie everything together, forcing the building to move as one single rigid unit. And finally, you've got to reinforce the brittle spots. Brick breaks easily, right? So you run steel reinforcement vertically through the corners and where the walls meet. This steel acts like a spine, giving the building just enough flexibility to absorb an earthquake's energy instead of just snapping. The bottom line is that smart geometry and some strategic reinforcement can turn a pile of loose materials into a resilient box that refuses to shatter. Because when the earth moves, you want your walls to move with it, not against it.